All right, we're looking at the IM1 Stats Day 3. So we're looking at some compound sample spaces and probability. So we're going to continue to look at sample spaces like we did the last couple days, but we're going to introduce a little bit of probability here to you guys. So taking a look at the Day 3 vocabulary there, we have outcomes, sample space, and probability. We're going to talk about the complement of an event. We will define that, and then also tree diagram. Okay, let me get rid of the comments there. Sorry. All right, so looking at the warm up here, considering the 7 days of the week, suppose the name of each day is written on a separate piece of paper and tossed into a bag. And when you reach in and choose one piece of paper, determine each probability. So the probability of choosing a day that starts with the letter S, well, that's going to be Saturday or Sunday, right? So the probability of that happening is 2 out of 7. The probability of you choosing a weekday, well, that's Monday, Tuesday, Wednesday, Thursday, or Friday. That would be 5 out of 7. And the probability of you reaching in and choosing Wednesday out of the 7 pieces of paper in that bag there is going to be 1 out of 7. So these are just ways to represent probability. In our first example here, we're considering this game, and we're spinning the arrow here around the spinner, and we're considering the possible outcomes. Now, when you spin this thing, you can land on any one of the 3 ones, any one of the 3 twos, any 3 of the 3 threes, or any of the 3 fours. Now, when we list these out right here, this is what's called a sample space, okay? So this sample space lists out all of the possible outcomes. Now, when it asks for the probability, in other words, like the likelihood, right? So if we look at the definition here of probability, the probability of an event is the ratio of the number of desired outcomes to the total number of possible outcomes. So if we're considering the number 3 as the desired outcome, or just kind of the identified outcome, out of the total possible outcomes, if you count the total possible outcomes here, that's going to be 12, right? Now, how many times does 3 occur? 3 times. So 3 out of the 12 here, that's going to be our probability of spinning a 3. And that comes out to a 25% probability. Part C, what is the probability of spinning a number greater than 1? Well, that's all of these numbers right here, the 3 twos, the 3 threes, or the 3 fours. So that right there is 9 outcomes out of the total 12 outcomes, and that gives us 75%. Now, this is another way to kind of organize your list. This is another way to come up with a sample space. You can put it in a little table here. All this simply means is, we have 1, 2, 3, and 4 as the outcomes. What is the probability here? Well, that's 3 and 12. Okay, let's clean this up a little bit. That's 3 and 12. Okay. This is also 3 and 12, and this right here is also 3 and 12. Now, each one of those come out to 25%, right? So that equals 25%. Let's speed this up a little bit. That is equal to 25%. Now, this guy right here is also equal to 25%. This guy right here is also equal to 25%. And this guy right here is also equal to 25%. Now, all of those together ultimately are going to equal 12 out of the 12 possibilities, which is going to equal 100%. I mean, it's impossible to spin a 5 here, right? Because that's not one of the outcomes. So those are all of the probabilities of each of the outcomes. Now, what is the probability of a spin not resulting in a 3? So that would be any one of these 1s, any one of those 2s, or any one of these 4s. Okay, so we're basically just eliminating the 3s. Okay, so the probability of not a 3 is 9 out of 12, or 75%. And this is what's called the complement of an event. If we're considering not the likelihood of an event, but the likelihood of it not being that event, that is what's called the complement. Okay, so the probability of a 3 is 3 out of 12, or 25%. The probability of not being a 3 is 9 out of 12, and that's 75%. So the complement will always add up to the actual event, and the complement of the event will always add up to 100%. All right, so example 2. Similar to the example above, okay, but we have different tokens here. We have cylinder tokens, which I've designated as CY, cube tokens, which I've designated as C, and pyramid tokens, which are designated as P. So the sample space here, because we have 6 cylinder tokens, there are 6 cylinders here. We have 4 cube tokens, so I have 4 C's here, and 2 pyramid tokens, so there's 2 P's there. So that is one way you could list your sample space. Now the probability of choosing a pyramid out of the 12 total tokens is going to be 2 out of 12, which is 16.7%. And the probability of a cube, well, there's 4 cubes here out of the 12 total tokens. That's going to be 33.3%. Now, again, if we organize this into a little table here, what is the probability of drawing a cylinder? That's going to be your 6 out of 12, or 50%. All right. This guy right here, what's the probability of choosing a cube? We already said that was 4 out of 12, okay, which is equal to 33.3%. Not 5, sorry, 3%. And then this guy right here, the pyramid, that's going to be 2 out of 12, right? And 2 out of 12 comes out to approximately 16.7%. And as stated above, if you add all these probabilities up, 50 plus 33.3 plus 16.7, again, that should add up to 100%, because you're not going to reach in and draw something out other than a cylinder, a cube, or a pyramid. Those are the outcomes. Now here is a complement problem again. What is the probability of choosing a token that is not a cylinder? That's going to be 6 out of 12. Not a cylinder would be either a cube or a pyramid. That is 4 events and 2 events, so that's going to be 6 out of 12, or 50%. Our final example here, we're looking at Mario's Pizzeria, and here are his deals. You can choose either a large or a small pizza. In each case, you have to do one topping. Cheese is not an option, so you can either choose between pepperoni or mushroom. And you have to choose either a square pizza or a round pizza, and you have to choose either thick or thin. So of those 4 options, like, you have to answer something. Like, I'm going large pizza, I'm going round, I'm going thick crust, and I'm going pepperoni. And that would be one of the outcomes. So Amalia and Romeo sketch their 2 what's called tree diagrams here. Now analyze these, take a look at them, see if you can make sense of them. I would encourage you to pause the video and just kind of look through and see if you can make sense of what they're saying here. So they're both correct, okay? They both end up with 16 outcomes here, okay? So how many outcomes are included in the sample space of each tree diagram? That's going to be 16. Now, this may be a little bit funky to look at first, but what this means, for example, this guy right here, let me highlight it. It's very important to understand what this is talking about. This pepperoni right here refers to a pepperoni that was thick crust, that was square, and is a large. This pepperoni right here refers to a thick crust, a square pizza that was a small. And this guy down here is a mushroom pizza on a thin crust that was a round pizza that was a small. So basically all of these final outcomes here all tie back into a beginning. This is pepperoni on a thick crust on a round pizza that is large. Okay, and if we list all these things out, which you will in just a few moments here, in each case with Amalia and Romeo, there are 16 total outcomes. Okay, what does each outcome of the sample space represent? And again, these are outcomes: pepperoni, mushroom, pepperoni, mushroom, pepperoni, mushroom. If you kind of branch your way back to the beginning, those are different outcomes. These just represent different types of pizza. Now, comparing the 2 tree diagrams created, how are they similar and how are they different? Well, they both end up with the same number of outcomes. If you count the ones along the side here, there's 16. And if you count Romeo's as well, there are also 16. How are they different? They just choose they basically answer the questions in a different order, right? They're all mandatory questions. Like Romeo chooses his large or small here, whereas Amalia starts off by answering large or small. Romeo starts off by having you answer either square or round, whereas Amalia, that's the second question she asks, right? So the order of the questions don't matter necessarily. They don't, because you're going to end up with the same number of outcomes. So does the arrangement of the tree diagram affect the number of total outcomes? Nope. We are just choosing the different varieties of our pizza in a different order. Now here's your sample space. This is where it gets a little bit tedious. If you use the tree diagram to make an organized list, basically what I'm saying here is this is a square, thick, large pepperoni. So square, thick, large pepperoni. Here we have square, thick, large mushroom. So I have that right here, square, thick, large mushroom. Here I have square, thick, small pepperoni. Okay, and that's right here. And basically you're just going to make your way down each one of these branches, square, thick, small, mushroom. That's right here, square, thick, small, mushroom. And you're going to list out all 16 of your sample space. Okay, and again, I'd encourage you to pause it and try it on your own. Ultimately, once you do that, we're going to answer these questions. So how many possible round pizza specials can you order? Well, that's all of these guys right here, right? It's all of the guys right down here at the bottom. Basically, you're not considering any of the square pizza options. So you're just looking at pepperoni, mushroom, pepperoni, mushroom, pepperoni, mushroom, pepperoni, and mushroom, right? So we're just looking at, clean this up a little bit. Sorry about that. And it got rid of all of it for me, so I'm going to leave it there. It's just looking at those 4 pizza options because those all branch back to the round option, okay? So how many possible round pizza specials can you order? There would be 8. How many possible thick and round pizza specials can you order? Well, let's see. Thick and round are going to be these guys right here, okay? Just those guys. So our final are just these 4 pizzas right here. So we have round, thick, large pep, round, thick, large mushroom, round, thick, small pep, or round, thick, small mushroom. So we only have 4 options there. And then lastly, how many of the possible pizza choices are square but do not have mushroom, or in other words, square with pepperoni? Same thing. We're going square with pepperoni. So that's this guy, this guy, this guy, and this guy. So there are 4 options there as well. All right. If any of that was confusing, try watching Khan Academy. He explains sample spaces a little bit differently, and he probably explains it better than I do. But if you have questions, write them down. Go to your teacher, ask them questions, ask them. They'll be happy to help you, and you'll be in great shape. All right, guys, give that self-assessment and portfolio a try.